In this presentation, we learn data center cooling technique and scope of CFD modeling for its design. We all know data center has been used in lot of corporate industry like Facebook, Google to store data of user. Data are stored in server rack, and these servers should be cooled, otherwise this server will be susceptible to the fire. We also learn what are different types of cooling techniques used for modern data center, and in order to design a data center, CFD will plays a significant role for its design. Here we can see a 3D model of data center with a CFD result. We can also learn what are essential input required for modeling of data center. Don't forget to subscribe this YouTube channel and watch this video till the end to get more information on data center and its modeling technique. Outline of presentation is given in brief. First, we'll learn what is mean that data center. Then, what are components of data center cooling? What are different room air conditioning units used for data center? Then we'll learn how CFD can be used to design data center cooling technique. We also learn how to create 3D model of data center in ANSYS space claim. Then we learn what are key input required for modeling of data center. This is a data center. This is the CFD model. And this is a sectional view of data center to see the flow pattern inside the data center. At the end, we learn some case studies based on CFD analysis. CFD modeling of data center cooling consists of two parts. There are two videos will be uploaded on YouTube. In first lecture, we will focus on cooling mechanism of data center and scope of CFD modeling for design of data center. This is covered in this presentation at the end, and watch this video till end. We'll get lot of information how to model a data center. In part 2, we'll focus on how to create geometry for data center, then how to create meshing in ANSYS meshing platform, and how to simulate data center using ANSYS FLUENT. All these things we can learn in part 2. Don't forget to watch video, and this video will be uploaded in few days on this YouTube channel. What is data center? Data center consists of a large number of uh, computer server which are placed inside this rack, and there are a lot of uh, servers are there, and these servers are placed in a different compartment as per the requirement. See, you can see here a lot of compartment are here across the row, and which are connected each other through wiring. And this is a one rack, this is a second rack, and there can be n number of the rack in data center. And all these racks are placed in cold and a clean environment. There should not be any dust, and and it is placed in air conditioner environment so that temperature of server will not increase. If we don't provide uh, uh, cooling of data center, then it will catch fire, and it will burn whole the data center. As data center comprises a lot of plastic component, basically which are insulation around the wire, or maybe the hardware part of this server. Due to continuous heat generation in server, temperature increases, and plastic uh, parts are made of uh, heavy hydrocarbon, and uh, it react with air, and we get uh, uh, fire in data center. In order to avoid this fire or any risk, data center must be cool in order to maintain high safety and long life of data center. This is a single rack of data center. Each rack of data center consists of the door. Both doors are closed. At at the top of data center, smoke or heat detector is placed during the extreme condition. There can be power distribution, row cooling, and IP camera is also there to monitor the rack for safety purpose. Here we learn what is data center cooling system. This is a data center, and this air get heated when it passes through this data center, and it flows out from the room of data center, and this heated air passes through this RAC unit. It is called as a computerized air conditioning unit, and air is always flows in between data center and RAC unit. There is a circuit of air channel between data center and RAC unit. This hot air passes through RAC unit. Each temperature reduces, and cold air flows through bottom floor, and then it flows through these perforated tiles. And the amount of heat generated by server is dissipated into air. Air absorbs heat energy from server, and air gets heated, and the heated air passes through this RAC unit. RAC unit is connected with a cooling coil, and cooling coils are connected with chiller unit. RAC unit may consist of humidified and dehumidified in order to control relative humidity. We have to also understand cooling circuit if we are interested to design. On the left side, here is the server room is there. Server are placed to the elevated floor. It is also called as elevated floor or raised floor. The hot air passes through this uh, room air conditioning unit, and this RAC unit is connected with chiller. In between chiller and RAC unit, there is circulation of the water, and cold air removes heat from the hot air, and it get heated, and this heated uh, water passes through chiller, then it is removed by another water circuit which is connected with cooling tower. From cooling tower, heat is released to the atmosphere. That means there are three fluid are used. There are three cooling circuit. One is uh, air circulation circuit in computer room, other in between a chiller and CAS unit, and third is cooling tower and chiller. This way, a cooling circuit is presented. For data center, they can use a large cooling tower if heat load is very high. As explained in previous slide, there are three cooling circuit. One is in computer room. Here is a air circuit, air cooling circuit, air flow circuit. Then in between chiller and CRC unit. Then third between is between cooling tower and chiller. Cooling tower and chiller are placed outside the computer room, and server room is connected with main building, which may be connected to the computer service center. Here I have presented flow pattern in data center. we will understand how cold air absorbs heat, how it get heated, then passes through the CRC unit, then again passes through this lower floor. The temperature of cold air for data center is in between 10 to 20 degrees Celsius, and the bottom floor, this is called as raised floor, through which cold air flows, then passes through this perforated tiles in between cold slate part, then it passes through this server, because server also has this perforated uh, opening. On both sides, servers have perforated opening to pass heated air. Its temperature may be around 40 degrees Celsius, 40 to 50 degrees Celsius, because most data center is a design maximum temperature is around 50 degrees Celsius. It may, in Kelvin, it may be around 330 Kelvin, not more than it. Sometimes perforated tiles also placed here to pass to the hot air through this plate, because you put this perforated plate here, perforated sheet, then its performance could be better. Here you can see ceiling is provided, hot air is taken through opening to the ceiling passage. This is called ceiling passage, because it has to keep hot and cold air to be separated, because hot air rises upward and it is sucked through top hot channel, then it is taken back to the CRC unit where it is cooled, then cold air passes through again uh, through bottom perforated plate. Because this raised floor, the cooling will be more effective. For small data center raised floor, it is not required. You can blow air from the bottom side to cool the server. Here stream lines of hot and cold air are presented. There can be possibility of interaction of the hot stream. Hot stream here interact here. Then all the hot air is returned to the CRC unit. What are different approaches used to cool the data center? There are many approaches have been used to cool the data center. One of popular approach is hot Ashley and cold Ashley approach. In this approach, hot and cold passages are created between racks of data center. Here you can see there are in between two racks of data center. There is a perforated plate through which cold air passes upward. Then it passes through the data center, and in hot SL unit, hot air is collected. Then hot air is taken to the to pre-air conditioning unit, and pre-air conditioning unit cooled this hot air. This is the one rack of data center. It can has a number of data center. Similarly, we can add a number of hot and cold channels in data center to cool a large size data center. Hot isolate and cold isolate approach is one of popular technique to cool data center. In this method, cold air is allowed to flow between two racks using a perforated plate at the bottom, and cold air passes through data center. It gets heated, and hot air is collected between two racks is called as hot SLA compartment. Then this hot air is sucked in precision air conditioning unit. For large data center, it consists of a large number of hot SLA and cold SLA unit. Here the same approach is presented. Here you can see the bottom floor is supported with some steel structure, because in bottom floor is to store the cold air which flows through this cold SLA unit. Then it passes through data center. Then hot air is taken to the RAC unit. Here some pictures of data center are presented. How the structure of perforated plates are used in data center. Here you can see circular holes are used, and here you can see there are rectangular slots are there. Which hole pattern is better, that will be decided by the designer of data center. Here you can see perforated tiles are near the data center. It passes through this rack. Each on the each compartment there are perforated doors are there through which this cold air flows. You can see the here openings are there. To enter the cold air, precision air conditioning is one of popularly used RAC unit for data center. It controls the temperature and humidity. It also remove a large sensible heat generated due to machine, and it is designed to provide high ratio of sensible to total uh, cooling capacity. And this unit is similar to the home or commercial air conditioning unit, but it removes more sensible heat due to data center. The design of a precision air conditioner is done as per data center. One of design parameter is precise humidity control. It is also designed to provide low and high humidity level for long operation. Room air conditioner are designed for a few months. Generally, we use RS air conditioner for summer, and that AC can be 3 star, 3 star, 4 star. That means it can be used for 3 months or 4 months. It cannot be used for all 365 days. But precision air conditioner are used to work for all 365 days. Hence, its maintenance cost should be low. If any failure in PAC can lead to huge loss due to a failure of data center. A PAC unit must be able to manage high heat, high level of sensible heat, because room ACs are designed to manage both latent heat and sensible heat emanated from people, because people is a major heat load. But for PAC unit, it designed to handle both humidity and sensible heat. The majority of heat load is sensible heat load. PAC units have higher flow rate compared to the uh, room air conditioner, and it has automatic control for efficient cooling. Computer air conditioner unit also used for cooling, but it is used for the low capacity, and it is similar to the traditional air conditioning. Its design is a simple. It consists of the filter, cooling coil, humidifier, dehumidified, and fan to supply cold air. It is used for a small capacity of flow rate. For small data center, we can use the CRAC unit, and it is designed to maintain temperature, humidity, and air distribution using direct expansion refrigeration cycle. It has to maintain pressure in floor because lower floor should be kept at a high pressure. Similar to the computer, seriously, computer room air handler is also there. It is useful for the large size data center. In this case, uh, a cooling coil is connected with RAC unit. Because of that, its size is large. For the purpose of brevity, we can get lot of literature on data center cooling, but this presentation is focused to understand scope of CFD modeling for data center. How CFD modeling will help to design data center. It, it will help to find out number of racks required in a room for effective cooling of data center. We can also assess performance of PAC or CRC unit. We can also find effect of supply temperature on performance of cooling system. We can also find out effect of ambient condition on safety of data center. Due to ambient condition like extreme summer, the heat load on the PAC unit may be high, and its performance should be optimized. CFD simulation will help to find out what's a critical server which is prone to fire. High temperature spot can be determined using simulation technique. Overall, modeling will help to optimize the performance of data center. Before going to modeling, we have to understand what are input data required to create the model. First, key input for data center after you have 3D model is volume flow rate, because volume flow rate is one of critical input. Then supply temperature, it should be fixed as per design input. Ambient temperature should be known, and total number of server or rack, because volume flow rate may be given on server basis or rack basis, that should be specified. Total number of PAC and CSU unit, that should be known, because all this information you get from their drawing. Grill size and opening area. Around a PAC unit, the grills are placed, and the size of grill should be known. We must know heat load for the rack, and lighting heat load uh, cannot be neglected because it may add some heat load. There may be additional heat load due to transferring of heat from surrounding to the uh, to the data center. Compared to among all heat load, the heat load for the rack is high. It is in order of 300-400 kilowatt, depending on how much servers you have placed in a rack, and that heat load uh, is distributed among the among the server, and that heat is absorbed by air. What are steps in CFD modeling? First is pre-processing. We have to make a 3D model of fluid zone. Then you have to mesh and give names of boundary condition. Then simulation in CFD solver. The solver setup, boundary condition. Among boundary condition, mass flow rate and inlet temperature of air is important. Wall heat load must be specified. Outlet pressure must be specified. Numerical scheme should be given proper numerical convergence of heat fluxes, and after convergence we have to do post processing and results analysis. These are major steps in CFD modeling. Volume flow rate should be clearly defined. Volume flow rate, inlet temperature, and the heat load. These are the critical input for the CFD model. If heat load, we can get how much heat is consumed by the data center. It is in order of kilowatt, and this heat load must be given as a correct wall flux or any volumetric heat load in a CFD model. This is the 3D model of data center. This is first rack, second rack, third rack, fourth and fifth rack of data center. This is a cooling compartment through which cold air flows. It is also called as cold air sleigh. This is a PSC unit. PSC unit are both sides of rack. We can consider the opening to the rack through which air flows. This is the concrete block. We don't need to model for CFD simulation. For simulation, we can consider only fluid domain. For simulation, for CFD simulation, we can consider only fluid domain in data center. we don't need to model whole PS unit. We can discard the solid compartment. Here these frames are given. These are the screen of grill sheet, because grill are attached to this frame for good distribution of air in data center. After completion of this model, we can use for the CFD simulation. We can, if you want to see how bottom floor is looking, we can see here. Just I hide the face. Here we can see. This is the bottom space. It is also called raised floor, through which cold air flows. Cold air flows is in bottom floor. After 3D model is created, we can use for the meshing. After meshing, we can use any commercial or open source CFD solver to get result. This is one of case study of data center with 12 server. Here 12 server are heated and heat is removed by the cold air. You can see here cold air flows through the middle perforated plate. Then it flows through the server. The heat circulates through the room, and then it again passes through the PS unit. And where at the outlet, this is the outlet, hence here temperature is high. Temperature can increase up to 340 depending on how much heat load is supplied. This is the sectional view of data center, and streamlines are colored with temperature. Cold air flows through the middle passage, then it flows through server, then again it flows up. That means there is a continuous circulation. This way we have understood importance of CFD modeling for data center. Don't forget to subscribe this YouTube channel. Thanks for watching this video. This is one of case study of data center. This is one of case study of data center for which CFD results are presented. Velocity contours are presented here. Low velocity is observed in data center, presented with blue color, and maximum velocity for data center is around 6 meter per second. 6 per meter per second means is around 20 foot per Second, here you can see the sectional velocity control. Most important CFD result is temperature control, because that we should be checked properly. For this data center, maximum temperature is around 50 degrees Celsius. Lower temperature is at bottom floor. It is raised floor. Here you can see the middle racks which has very low, very high temperature. This is cross sectional across cold compartment. In cold compartment, temperature is low. Here temperature is around 20 degrees Celsius. And this is the temperature control in hot compartment. That means this is compartment. In between, this is hot compartment. In this section, the temperature is coming high. This is a cold. This is cold compartment. This is hot compartment. This is also hot compartment. In this hot compartment, we can see the increased temperature of air after passing through a server. This is a cold compartment where air temperature is quite low, because cold air flows through bottom floor. It open through perforated plate, then it passes through perforated doors of server. This way, CFD simulation can be used to find out hot and cold spot in data center. Thank you for attending this lecture. For more information about CFD analysis of any problem using ANSYS FLUENT and OpenFOAM, you can visit website www.com CFD Flow Engineering. It covers most of the important topic for engineers, scientists related to the CFD and flow engineering, and also covers topic for flow technology. Thank you for attending this lecture. God bless you.